Welcome back. In this lesson we're going to look at calculating the surface area of geometric nets and complex shapes. We're also going to look at using a formula to calculate the surface area of cylinders, spheres and cones. As always, if at any point during this video something doesn't make sense or you don't quite understand, press that magical spacebar, pause the video, come and ask me for help and I will gladly help you or explain it in a different way. Let's go. The surface area of a three-dimensional solid with plane faces is the sum of all our faces. That's what we're talking about with the surface area. So if we want to figure out how much area of each face a solid object has, we can break it up into each individual face. So here if we have this shape that we've got here, I can go, what is the surface area of this face here, this face down the back, the base, and the two ends, and that's the total surface area. Another way to think about that is if this was made out of paper and I cut it and folded it out, I end up with this shape. And this is what we call a geometric net. This is the thing that if I cut this out in paper and folded these lines, I would end up with this shape. So I can flatten the object out and measure the area of each of these shapes, add them all together, and I have my total surface area. Time for some practice. So now we've got a bunch of different shapes, both relatively simple in terms of box shapes, we've got pyramid shapes, and we've got sort of combinations of both. Have a go at finding the surface area of all of these using the information we've just talked about. Pause the video now, answers will be up in 5 seconds. Now we're going to look at cylinders. So this video will go through how we get the surface area for a cylinder, depending on whether it's got open ends or closed ends. There are different types of formulas. So it'll go through how we figure that out. And then at the end, it'll give you what those final formulas are.
And let's say it has no top and no bottom. So it just looks like a toilet roll. I wanted to know what is the surface area of that. So how many surfaces has it got to start off with? Well, if it's got no top and no bottom, that's not a surface. It doesn't take up any space. So all I'm left with is the circular section. If I take a normal looking toilet roll and I cut it down the middle and fold it out, notice that the shape it makes is just a rectangle. So my cylinder with no ends is equivalent to just a plain old rectangle. So now I just want to know, well, what's the area of this? We know it's length times width, base times height, whatever we call it. But here I'm often told the height of a cylinder, but I'm not given a width, right? Because they give me a radius, but the radius is not the same as the width. If I know how far it is from here to here, that's definitely not the same distance. But hopefully, if you see that if I take this and roll it up, the distance from here to here is the same as the distance around the cylinder. So this length is actually equal to the same as the circumference, which is R2 times pi times R. So now that I've got this, that means its width is actually my height. So the surface area of an open cylinder is 2 pi R times height, where R is my radius, height is just the height of the cylinder, and pi we can put in our calculator, 3.14. Now if I consider a cylinder with a top to it, so I have my same cylinder, but in this instance it's got a lid. It's got no bottom, but it's got a lid. Well, I need to know, what does this shape look like if I cut it apart? How many pieces are there? There's definitely a circle, and then the body part we just talked about will give me a square or a rectangle depending on the cylinder. So I need to know what's the area of this thing and what's the area of this thing. This is just a circle, so that's just pi times r times squared, where we're given the radius. And this is our height. This, the area, is exactly the same as what we did before. So if this was the open cylinder, we've taken this same surface but now we've added on a little bit, and that little bit is the top, the pi r squared. So this bit here is the area for a cylinder with one lid. So if I rewrite that here, this is surface area. Starts off looking the same as the one with no lid, but now I add a single pi r squared because it has a lid. Now there's one more case, and that is if I had a cylinder with two lids. So if I take the cylinder that I started with, I have my one lid, but now it's got a bottom, it's got two lids. The surface area is what I'm trying to find. Well, so far it's still got the same body, which is my height, and I'm told the radius. So I've still got this. 2 pi r times height is this main body section. So I can just straight away write that down. And a pi r squared is the area of a top. But now I've got two of them, so I would just have another 2 lots of pi r squared. And that is the surface area for a cylinder with 2 lids, a top and a bottom.
So the 3 formulas that we care about are here, whether we have a hollow, an open end like a tin can, or if it's a completely solid cylinder. So I would highly recommend you write these 3 down in your book. They're very useful formulas. Here we've got 2 pi r times h. Here we've got 2 pi r times h plus the end, which is a pi r squared because it's just a circle. And in this case, we've got 2 lots of the pi r squared because there's 2 ends plus the 2 pi r h. And the video we just saw talked about where this pi r h part comes from. Here we've got an example of a cone. So if we would fold out a cone into a geometric net, we would have this sector piece here, which makes the cone part, and we have the circle at the top, which is just a circle. So if we add each piece up, we've got the arc of A to B. So that's going from A to B. That's how we would describe an arc. That's 2 pi r. And we also know from what we saw before that it's some percentage, some ratio of a full circle, which is 2 pi s. In this case, we're using s for this length here, which is just your radius. And that's just 2 pi r in this case. So s is the slant height. And that's why they've used s here. So on a cone, s is the slant height. But once we've rolled it out into a flat object, we know that s is just the same as r for the radius of a circle. So therefore, we combine all this together and we end up with this pi times r times s equation. So for the curved section, the slanted section of the cone, pi times r times s is our equation. And then our final 2 equations are for a hollow cone, like an ice cream cone, pi rs is the equation. And for a solid cone where it's got the end on it, it's the pi rs plus the circle, the pi r squared on top of that. So here's an example of how we would solve a couple of different questions for surface areas. The sphere here we'll talk about in a bit more detail later, but surface area of a cylinder, a cone, and a sphere, we have the workings shown as well as the equations. Time for some practice. So have a go at these questions here. Pause the video, answers will be up in 5 seconds. This concludes our video on surface area of complex shapes and geometric nets. I'll see you next time.